Hello, Algebra 1 students. This is Miss Wiley, and today I'm going to talk a little bit more about the information in section 5.4, along with what we had just recently talked about in section 5.2, which is solving systems by substitution. So we had already talked about different solutions of a system of linear equations. So just to review that really quickly, on page 149 of your student journal, you will see that we talked about that you can have one solution, which is a point of intersection. We write that as an ordered pair, x comma y. We could also have no solution. No solution would mean that your lines do not intersect, which is the definition of parallel lines. And parallel lines, as we know from chapter 4, is that they have the same slope. The third type of solution we can have is an infinite solution. Okay, and with infinite solution, it's the idea that your lines coincide, or you in fact have two lines that are exactly the same. The lines are the same. They mentioned that down here. Okay, so whenever that happens, that means that the two lines essentially intersect the whole way. So they're constantly intersecting, and we know that a line goes on forever and ever in both directions, so it goes to infinity. So therefore, infinite points of intersection. So infinitely many solutions. And you can just say infinite solutions. You might even, instead of the word infinite, you might use the infinity symbol. That's fine too. All right. So let's talk about what happens when we solve something algebraically. We had already talked about solving it by substitution and getting an ordered pair or a point of intersection as our answer. We're going to look at an example here. I'm just going to use this space down below here to do an example. So I'm going to draw a little line here and write down a problem. The problem that we're going to do is we are going to solve, and we're going to solve it by substitution, since that's what we had just recently talked about. And we're going to solve the system x minus 3y equals 6. And the second equation in the system is 3x minus 9y equals 18. Now remember, in order to use substitution, you need to have one variable by itself in at least one of the equations. So far, we don't have any variables by itself in either equation. But what you're looking for is you're looking for maybe a variable that has a coefficient of 1 or a coefficient of -1. If that doesn't occur, you're going to see next class, we're going to learn another way to solve these, which will help us to do those types of problems. It would actually even help us to do this problem. But since we haven't learned that method, we're going to change the way this problem looks. So I'm going to go ahead and change equation 1. So let me label these equation 1 and equation 2 as I talk about them. So in equation 1, I'm going to easily change it by adding the 3y to both sides. And that's going to give me x equals 3y plus 6. And my second equation, you can rewrite it if you want to, or you can leave it where it is. I'm going to go ahead and rewrite it. I'm going to leave it exactly how it was. So now what I have is I have something that x equals. I have a variable isolated, so substitution method will definitely work. So since I know what x equals, I know x is 3y plus 6, I'm going to take that and I'm going to plug it in for x right where I see x. So I'm going to plug it in. Here's my little plug. So make sure that you're only plugging it into x, not 3x. Okay, so that's kind of why I like to put a little parenthesis around what I'm plugging it in for, so it only takes the place of that. So now I'm going to take this and I'm going to rewrite my second equation with my 3y plus 6 in place of x. So instead of 3 times x, it's going to be 3 times 3y plus 6. So here you can see the parentheses are really important because that 3 needs to be applied to both the 3y and the 6. And then just continue to write everything else exactly as you see it. So copy minus 9y, copy equals, copy 18. Now I'm going to go ahead and simplify this by distributing first. So it's 9y plus 18 minus 9y equals 18. Continuing to simplify, I want to combine like terms so I can continue solving for y. My like terms on the left are 9y and negative 9y, which actually ends up being 0. They cancel out. So what I'm left with is 18 equals 18. So what you can see is that my variables have now canceled out. And what I'm left with is a statement that is actually a true statement, but I just don't have any solutions to my variables. Now, this does not mean that it's automatically no solution, because remember, we have 3 options up above. We have a point of intersection, which that didn't happen because I didn't get a value for y. It canceled out. So our 2 options that are left are either no solution or infinite solution. So we need to talk about what this one is going to be. Okay, so we're going to go ahead and we're going to write down some information about this. You may not have room here. So let's just go to the next page and we'll write it on the next page. I think that's okay, because we're not going to do all the problems on the next page. So I'm going to use some space down here on the next page to talk about this. Okay, so let's look, just use the bottom of page 150 to write some more notes here, because we're not going to do these problems. So basically what happens if the variables cancel out, there are 2 things that can happen. One thing that can happen is you get a true statement, which is what happened to us when we did the problem. If that happens, that could be something like 0 equals 0. We had 18 equals 18. So something like that. So the variables have canceled out and you're left with a true statement. This is going to be, well, let's take a look at Desmos and see. So I'm going to quickly click over to Desmos. I already have these in my Desmos graphing calculator. So this was our first equation. So there it is. And then here is our second equation that we had there. And there it is. Notice what happened. Those 2 lines are exactly the same line when we graph them. So there's where the green was, and now it is overlapping now with the purple. So there it is. So we can now say that because of that, they're the same line. We know that the answer is going to be infinite solutions. Okay, so we can go back to our problem here. And even though we know this is true, that's not the answer. We need to answer this and say that our answer in our example back on page 149 is going to be infinite solutions. So that's what I would put there. Okay. Now remember, the other options is it could have been parallel. You can tell lines are parallel by seeing if they have the same slope, but neither of our equations are in slope-intercept form. So you don't necessarily need to know the slope. So what will happen with a parallel line or no solution type of problem is you have your variables cancel out and you get a false statement. When this happens, that's going to be something like 0 equals 5 or any false statement. But variables cancel out. You get like something like 0 equals 5, and that's definitely not true. This is going to be a problem where your answer would be no solution. It would also be a problem where you have the same slope. right? So if you can recognize that it has the same slope by putting it into y equals mx plus b form, that's another way to tell. Okay, with the infinite solutions, you could put both of the equations into y equals mx plus b form and have it be the same. And if you see the slope-intercept form is the same for both of them, you could ultimately say it's infinite solution without doing a substitution property, I guess. But normally I go ahead and I solve it using one of our 3 methods of solving a system, unless, so let's go up to our practice problems on page 150. If I look at number 1, looking at number 1, both of those are in y equals mx plus b form. And if you look, both of these equations, so both are in, let me write that down, y equals mx plus b, and both have a slope of 3. So I'm not really going to take the time to solve that by substitution. I can use my words to explain why I'm choosing to give the answer of no solution. And you could say, with both of these being in slope-intercept form, or y equals mx plus b form, I can see they have the same slope, therefore they would be parallel lines. Parallel lines never intersect. Answer is no solution. Though you could essentially solve that one and you would get variables to cancel out, and you would definitely get a statement left that is false. Okay. On number 2, I'm not going to solve number 2, but on number 2, they are both in y equals mx plus b form, right? So we have both in y equals mx plus b form, and they don't have the same slope. Okay, they don't have the same slope. And also, do you notice that they both, they don't end up being the same equation? Because if the answer was no solution, they would have the same slope. If the answer was infinite solution, their y equals mx plus b form would be exactly the same. So they don't have the same slope, and it's not, whoops, I skipped a word. It's not the same line, because the y equals mx plus b form is not the same. Therefore, this problem here would have some solution of x comma y. Now, again, I'm not going to take the time to solve this because we talked about these problems yesterday. But if you did want to practice solving this one on your own, the answer would be 3/5 comma 2. So you could take a moment and you could practice that one off to the side maybe and see if you get that answer for some extra practice with substitution. All right. And then on number 3, this is a problem that again, I'm not going to solve it, but this might be a problem that you look at and you're like, oh my gosh, doing that by substitution might be really complicated. So on a problem like number 3, personally, I would wait until we learn our lesson on Thursday, which is the elimination method. It would make that problem a lot easier to do for sure. Okay, so overall, what I want you to recognize is that if they have the same slope, right, and they're in y equals mx plus b form, you can say no solution. But you can always just solve it, because you can solve it. And if the variables cancel out, there's 2 things that are going to happen. Okay, and you need to make sure that you can recognize those. If the variables stay in the problem, then the answer is going to be an ordered pair, x comma y. So I just want to really quickly, before I let you guys go back to Desmos and show you number 1 on the graph. So on number 1, we had y equals 3x minus 7. And then you'll also see in number 1, we had y equals 3x plus 4. And you can see that those are parallel lines. You could even count your slope if you wanted to, and see that it is 3 over 1 here and it's 3 over 1 there. So it's another way to check to make sure that you're on the right track with your problem. Okay, so after you finish this video, go to Big Ideas Online and work on the assignment that goes along with this to practice a little bit more with substitution and the idea of different types of solutions that could come up. So I hope this video helps, and best of luck with your practice.